Yeah. I've had coffee in like 2 weeks. I know you don't have
Okay, so we're still on 11.2. We're going to talk about part 3. So section 11.2 is about 11.2 is about finding limits algebraically. So what we're going to talk about today is finding limits, one-sided limits algebraically, and those usually come from piecewise functions. Why? Why are you whining? You don't even know what you're whining about.
Yeah, but it's a big word. There's the word function in it.
Mm-hmm.
Yeah. Remember, like,
Not hard.
I don't remember that.
yeah. There's a lot of work.
Mm-hmm.
Oh. Effects. Degrees.
Okay, so this is a piecewise function. So a piecewise function is called a piecewise function because it's defined in pieces. So it gives you a graph that has separate pieces. I don't even know. Like it has different chunks in it. And the stuff on the right is actually, we read that first because it gives us the domain for each piece. So that linear function, 2x plus 1, is only the graph when the x's are less than or equal to 4. So we know that in there, it would be a linear straight line. We know that in between -4 and 2, it would be like a parabola, it would be U-shaped. And then greater than 2, it's going to be something else. It's going to be that x cubed shape, but down. Now, what we need to be able to do is to find, well, let's say this. When we have a piecewise function, it does give us the opportunity to do one-sided limits, okay? So let's say I asked you to do the limit as x approaches -4 from the left of f of x. Okay, this does require just a smidge more writing, not a lot, like literally one extra step than before. But what you have to do is figure out which piece would be on the left side of -4. Okay, it's either the top or the middle, and I know that because those are the two numbers that involve the -4, or those are the two pieces. So is it the top or is it the top? How do you know?
Because it's equal to.
No, actually no.
Lower than.
It's lower than. If I'm coming from the left, I'm talking about numbers. Think about a number line. I'm drawing, you don't have any markers up here. Think about a number line. Right, here's -4. If I'm coming from the left of -4, I'm over here, and that is less than -4. And so then I'm looking at numbers less than -4. So then you would rewrite this with this piece, and then you would find the actual answer. And once you're there, though, there's no difference. It's still a limit, and you still plug the number in. No. It's -4, Javon.
Oh.
Yeah, so it's -7. Okay, now, what would be, okay, if I said the limit as x approaches -4 from the right, which piece are you using? Yeah, using the x squared, and then you just write it. And so the only reason you're writing this is for the person grading your papers, which would be me, so that I know where you're getting your information from. Do you understand what it means to come from the left side and which piece you're using? What's the answer?
16?
Yep.
Negative 16. Oh, wait, no, 16. Never mind. I forgot.
Yeah. Okay. How about the limit as x approaches 2 from the right of f of x?
Squared.
What's the answer?
Negative 12.
Negative 12. Correct. Which piece are we using?
The bottom one.
The bottom one. Because we're talking about 2, and we're talking about coming from the right side of 2. That's greater than 2, so we're using the bottom piece there. X approaches, what did I say? 2 from the right of negative x cubed minus 4 is negative 12. Okay, so let's try another one. Now that I've given you the idea, it's not difficult. So even though it's right and left hand limit, it's okay because it's just is what it is. So let's go 5x squared minus 3x plus 1 if x is less than 1 and 2x plus 3 if x is greater than 1. Okay, I'd like you to find the limit as x approaches 1 from the left. And I'd like you to find the limit as x approaches 1 from the right, please. You guys, somebody from Mawson came in 6th hour and he was like, I watched the video and I know the code words. So I had to give him a sucker too. It made me laugh. He's like, can I have extra credit? I was like, no, but you're going to have a sucker. Okay, so if we're talking about from the left, we're talking about limit from the left, the answer is what? It's 3. Okay, which piece are we using for from the left? Yeah, because we got 5x squared minus 3x plus 1. Because, again, if you think number line, we're talking about on the left side of 1, that's less than 1. And then just plug in your 1. So 5 minus 3 plus 1 is 3. Okay, from the right then is the only other piece I give you.
Ooh, I got this one.
What is it? It's 5. Okay.
I don't know. I feel like I'm in preschool.
Questions? No. What's the limit as x approaches 1 of f of x?
Nothing.
DNE. Okay. Now, why?
Because none of them are equal to.
No.
So like.
So you're on the right track. There is no hole. Look, this guy. So from the left, it's at 3. From the right, it's at 5.
There's not a function.
So let's just review what we talked about. This guy would look like something like this, right? This would be open. This would be open. right? This would be at 3, this would be at 5. So we talked about this when we did graphs. Why is the limit does not exist? Because the left and the right have to be equal. Okay, that would put that in our notes on the first day. The left-hand limit and the right-hand limit have to be equal. So even though this is a piecewise function, I can ask you this. It requires you to go back and do the left-hand and the right-hand limit. Oh, so much work. What? Ellen, what'd you say?
What do you mean, like, go back and do that?
Okay, so let me give another example. So you have F. Javon, the more you whine, the more I'm going to do.
These guys will complain about it.
I guess.
Christians might get touched by Andy.
Yikes.
Do you mean like the 3 and the 5?
Have to be equal.
Oh.
Why you get touched by Andy? It's true. He does it to himself.
Okay, there we go. So what I mean, Ellen, this should answer your question. If I said to you, I want you to find the limit as x approaches -3 of f of x. The only way to do this, because this is a piecewise function, I cannot just plug it in because I've got two separate pieces. So the only way to do this is you have to say, oh, I have to do two of these. I have to do the limit as x approaches -3 from the right. And I have to do the limit as x approaches -3 from the left. Okay.
So it just doesn't matter if it's equal to or not. Or this has like no use.
This you mean?
No.
This. No, it doesn't matter, right? Because you could have something like this, right? Where one is closed and one is open. You can have one like this, and it doesn't matter. It still has a limit, right? It still has a limit because they both are approaching that spot. From the right is x plus 7. Okay, now, what is this? What's this one equal? 4. What's this one equal? 4. So, because they are equal, then the limit as x approaches 3 of f of x is equal to 4. But there's no way to do it other than do the both sides of the limit. Okay, so let's do, just make sure you get what I'm throwing at you. Let's do the limit as x approaches 5 of f of x. Okay, I've not ever done it this way before, but this is probably the easiest way to show your work. Okay, and then go back and put your final answer up at the top. Totally acceptable. I would be happy for that. Which function do I use for the left of 5? X plus 7. Which one do I use for the right of 5? Okay. Then you guys, like, the limits are easy. It's not like you're doing a lot of ton of stuff here. What's the first one? It's positive 5 though, right? 5 from the left, right? So it's 12. Okay, what's the other one?
27.
27. So what's the limit as x approaches 5? Does not exist.
So if they're equal,
The limit exists and is that limit.
okay.
If they're not equal, it doesn't exist. Right? Because if they're not equal, then you've got this situation and the limit does not exist. And if they are equal, you've just got two different pieces that meet up in the same place. Okay, doesn't matter if, so the fact that these guys are equal or not equal, I think this is what Weston was talking about. If these are equal or not equal, doesn't make any difference at all. Okay, questions on this? I can't really make it any harder, which is always a nice thing. Okay, so let me give you your worksheet for today. Have a lot of time to do it.
What day is